Okay, this is our new chapter. Now there's going to be quite a few definitions and theorems and postulates for you to write down. We'll be going through all of these in class, but I am not going to take the time for you to copy down the theorems and the postulates and the definitions. You should already have them copied in your notes. If you want to leave room for other examples that we do in class, that's fine. Or after these, you can start new notes. Please remember at any time to pause. We're going to be doing 3 lessons. They all correlate to each other. The first one is identifying pairs of lines and angles. Parallel postulate. If there is a line and a point not on that line, then there exists exactly one line through the point parallel to the given line. Quite a mouthful. Let's look at a picture. Again, at any time, please pause. So here is your line and a point that is not on the line. This postulate states that there exists a line passing through that point that will make those two lines parallel. Perpendicular postulate. If there is a line and a point not on that line, then there exists exactly one line through the point perpendicular to the given line. Again, quite a mouthful. I'm going to draw a picture. Remember, you can always stop. So here's your line and a point not on that line. It's stating that there is a line passing through that point that is perpendicular to that line. This is your first definition, skew lines. Skew lines are lines that will never intersect but are not parallel. Think about that. Lines that will never intersect but are not parallel. Well, the only way this could happen is they have to be on different planes. Now, I'm going to draw an example, and I encourage you to put this example in your notes. So this example is talking about lines FG and BC. Notice FG is on plane FGB. BC is on plane BCD. FG and BC will never intersect, and notice they are not parallel. This is your second definition, a transversal. A transversal is a line that intersects at least 2 lines. It can intersect more than 2 lines, but it must intersect at least 2 lines to be known as a transversal. So in this example, lines P, Q, and R are all transversals because they all intersect at least 2 lines. Line R is a transversal because it's intersecting P and Q. Line P is a transversal because it's intersecting lines R and Q. And line Q is a transversal because it's intersecting lines P and R. Now you need to copy down this table. You need to copy down the names, the angles, and the picture along with transversal P intersect lines Q and R. So please pause this presentation to copy it. Notice there are some blanks underneath exterior and interior angles, so make sure you leave room for those. Now in this picture, P is the transversal that's intersecting lines Q and R. Now everything you learned in chapter 1 and 2 still applies. 1 and 3, 2 and 4 are vertical angles, and they are congruent. 5 and 7, 6 and 8 are vertical angles, and they are congruent. 1, 2, 2 and 3, 3 and 4, 4 and 1 are also linear pairs, which means they are supplementary. 5 and 6, 6 and 7, 7 and 8, 8 and 5 are also linear pairs, so they are supplementary. So please remember all of that still applies. But now what we're doing with this chapter is we're no longer looking at just a group formed by two intersecting lines. Instead, we're looking at a group of angles formed by two intersecting lines along with another group of angles formed by two intersecting lines, and they have a correlation to each other. So for exterior and interior angles, that's just for you to be able to identify where they're located. So notice where 1, 2, 7, and 8 are located. They're outside those two lines, Q and R. Those are known as exterior angles. The interior angles, 3, 4, 5, and 6, are located between the two lines. Now the other angles that I have listed, those have special names, and you're going to have to memorize those names because you will have to tell me what angles they are. So let's look at the first pair, 3 and 6. Look at where it's at. It's on the same side of the transversal P, and they're both interior. Look at the other pair, 4 and 5. Same thing, same side of the transversal P and interior. Well, that is known as consecutive interior angles. Now, in another textbook, for the regular geometries, they call this same side interior. I've always known it as consecutive, but it was the first time I ever seen it in a textbook, same side. So I'm going to put in parentheses when we start discussing these with examples. In class, I'm going to put same side, but we're going to learn it basically as consecutive interior angles. Now look at the next group, the pair 1 and 7. Look where it's located. It's on alternate sides of that transversal, and they're both exterior. Same thing with the other pair, 2 and 8. Those are known as alternate exterior angles. Now let's look at the next pair, 3 and 5. Look where they're at. They're also on alternate sides of that transversal P, but this time they're inside. They're in the interior, just like the other pair, 4 and 6. This is known as alternate interior angles. Now the last one has quite a few angles. Look where they're at. 1 and 5, they're on the same side, but one's on the outside, one's on the inside. 2 and 6, both on the same side, but one's on the exterior, one's on the interior. 3 and 7, both on the same side, one's on the exterior, one's on the interior. And same thing with 4 and 8. So we don't call these interior or exterior. Instead, they correspond to each other. I like to think of it as I'm going to a wedding. And 1, 2, 3, and 4 are all sitting at one table. 5, 6, 7, and 8 are all sitting at another table. But 1 and 5 is sitting at the same spot, but just a different table. They correspond to each other. It's known as corresponding angles. Now this next lesson is still dealing with those same angles you just learned, but now we're looking at it with parallel lines. Because something happens significant to these angles when we're dealing with parallel lines. The first one is the corresponding angle postulate. Remember, that's the one that had the most. We're only looking at one pair in these theorems and postulates. It states, if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. This only applies if the lines are parallel and they are cut by a transversal making those angles. Remember where the corresponding angles are located. One's above, they're both on the same side, and one's outside, one's inside. Same seat. Well, these are congruent. I could put angle 1 directly on top of angle 2. Alternate interior angles. Remember, there's another pair of these. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are also congruent. They have to be parallel. They have to be cut by a transversal. And remember where the alternate interior angles are located. Well, I could put 3 directly on top of 4 and it be the same angle. That makes them congruent. Alternate exterior angles. If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are also congruent. This only applies to parallel lines. You have to have a transversal to make these angles. And remember where the alternate exterior angles are located. There is another pair. I could put the 7, turn it around, and put it directly on top of 8, and they would be congruent. This is the last one, consecutive interior angles. Now, this one's different because look at them. Look. 5 is an obtuse angle, 6 is an acute angle. There's no way they're congruent. This one states, if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. Now, this only applies again to parallel lines. None of 3:1 applies to this because they were not parallel, our examples. We have to have a transversal, of course, to even make the angles. And remember, there is another pair of consecutive interior angles. They're on the same side of the transversal, and they're both inside. Now, I could actually move 5 below number 6, and they would be forming a linear pair. That's why they are supplementary. Now, 3:3 is your last lesson. It's the same thing as 3:2, except for now it's the converse. This is the way that we show the lines are parallel. Now again, I'm going to be just walking through these, so at any time, please remember to pause. I'm going to also use the same pictures. The first one is the converse of the corresponding angles postulate. If corresponding angles are congruent, so they have to be congruent, then the lines are going to be parallel. Alternate interior angles converse. If alternate interior angles are congruent, then the lines are parallel. Okay, so again, the angles must be congruent for it to be parallel lines. Alternate exterior angles. If alternate exterior angles are congruent, then the lines are parallel. So again, the alternate exterior angles have to be congruent to be able to have the lines parallel. And the last one, consecutive interior angles. If consecutive interior angles are supplementary, then the lines are parallel. Now, this is the end of your presentation. Please remember to go back if you were not able to finish copying some things. This is important because I am not going to give the time in class for you to copy these. I'm going to show it, and we're going to do an example with it. We're going to discuss it, and then we're going to do problems in class. Any questions? Please make sure you ask me in class tomorrow.